precedence, it's essentially the order in which operators and quickly I'll just put a little comment saying what operators are. Plus, minus, lambda, new, etc., etc. These are all operators. They operate on something, change it in a way. Order in which operators. It's the order in which operators are evaluated. So let's start off by, let's just go over the first operators in this list. Which are gonna, and it's okay, you're not gonna know every single operator that we're going over. We're just gonna go over the main ones here. So, and obviously we're going over, like, this is an accumulative video of operator precedence, right? It's gonna go over almost everything related to it. However, you're not in your sys because this is only episode 4, right? You're not gonna know all these operators yet. But what I want you to do is when we go over one of these operators in later videos, come back to this and just re-jog your memory. So first off, we have the parentheses, the new symbol for creating objects, the square brackets for indexing elements, and then lastly the dot for calling methods and properties of an object. So parentheses are pretty straightforward. Any operations like 3 plus 4 plus 5 happen that are happening inside of a parentheses happen first. So if I had this expression, 3 plus 4 plus 5 would be evaluated first, and then we'd add the 4 onto it, okay? New is kind of straightforward for operator precedence. Just know that if I was creating a new object, right? Say I had a class obj and I was creating a new object, then we would be evaluating first is this new keyword because to create this object, okay? And well, this is pure parameters, right? And you kind of don't think about this when you create objects, but it does make sense because if you're gonna call methods on this object, or if we're gonna like modify it, if we want to get anything from this object, it needs to exist first. And that's what this new keyword does. It takes this object and puts it in memory, makes it real, makes it something that we can access, that's tangible for the computer to access. Which is why it's one of the first things happening here. The next one is if you had a list, right? And we're looking at elements from the list. So let's say we said A is going to be equal to, and let's say we call the list elements, and we're just taking the second element. And let's say A is equal to that plus 4. Well, we wouldn't say that we're gonna do plus 4 first. We wouldn't say we're doing lm2 plus 4. That wouldn't make any sense, would it? What is lm2, right? That's the question you'd have, which is exactly why this is evaluated first. We use the index brackets to figure out what element is here. Let's say, for instance, it was 5. Now we could add the 4, so then we would get 9. So that's why, again, is one of the top ones here. And the same situation can be used if we had let's say we had an object called object, right? And then we looked at the first value, let's call it a number, and we wanted to increase this value by 2. Well, if we don't know what this is, how could we possibly increase it by 2 first, right? So this gets evaluated first, and then we add 2. So that's the first set of values. The next set is going to be the unary post and unary pre-increments. Now, what does unary mean? It means we're looking and applying this to one singular value, like one number. So let's say we had an integer of A is equal to 6. Well, what the unary plus operator does, or unary post increment, will turn the 6 into a 7, and then the unary pre operator, or the post pre increment is, sorry, it's called the post decrement and post increment. Sorry, I mix them up a lot. I'm not too good with the technical names. Just notice post increment, post decrement. I might call it the plus plus minus. I'm gonna call it whatever, you know. But yeah, the post decrement operator will just take the 6 and make it into a 5. Now you might be wondering, why is it called post? Well, it's because if it's in, let's say we're looking at A and we're saying it's 6 right now. A plus plus is equal to 7. Now you might be saying, Sid, that makes sense. We're going to add 1, it's going to become 7. This should give us true. Well, actually, when you run this in Java, this would give us false. This condition is not true. And why is that? It's because it's in post increment, we use the initial value of A for any evaluations or conditions we have to do, and only after that is all evaluated do we increment this to 7. So what would actually happen here is we would essentially C++ Java is essentially reading that as if A is equal to 7 and A is 6, and then evaluate that, and then at the very bottom here, let's do an A++. So what happens after this operator is done, okay? And the same can be said for pre-increment. This was minus minus, and this was, let's say, 5, not 7. This, yeah, right here, boom, boom, boom. This would be essentially looking at A, and then seeing if it's equal to 5. That's going to be false. And then it's going to be subtracting, okay? So make sure you understand that concept, because post and pre-increment get tested on quite frequently on especially in the first 15 questions. Well, it's really pivotal to let you understand that idea. Now we're going to dive into more unary operators. So we're looking at the unary plus, the unary, I think it's called the unary minus, the unary logical not, the unary bitwise not, or the tilde. Then we have the unary pre-increment, and then the unary pre-decrement. So what pre-increment and pre-decrement do is, and the way you'd see these written here, what I can do is I'll write an A here, A here, A here, and A here. So if we go back to our if statement example, and say we had int of A is equal to 6, if you did plus plus A is equal to 6 is equal to 7, well, you would actually see that this returns true now, because essentially what Java does when you're looking at a plus plus is it evaluates, it runs a plus 1 and makes it into 7 first. It does that first, and then it takes that 7, there's a new value of A, and then does the evaluation, then checks. So unlike how post increment, this expression would get evaluated first, the if gets evaluated first, and then we increase our value by 1. In pre-increment, the incrementation happens first, and then we do the evaluation, and the same can be said for the pre-decrement. Okay? Make sure you know the difference between this and this. Okay? Next, what we also have is the tilde, which we've covered. So it basically will take the bits of any number you give it and flip them. So it'll give you like a really, really big number. I don't know what tilde 5 is, but I know it's really big. Okay, that's tilde. And of course, remember these are unary because they're being applied for one singular object or number. That's why these are unary. Then you have the logical not, and it's logical because it only applies for conditions to those statements. So you have to have a statement that returns true or false. Logical not only will work for true or false if you were to try to do, so you're trying to run this. You will code with error out. That's illegal. That will not compile. Okay? And logical not, if a condition was true, return false. And then if a condition was false, return true. So basically just flip it around. Next we have the unary minus, which is not, this is not the subtraction sign. What this is essentially is it flips the sign. So if you had 20, A is equal to 20, and then you print it out, and I'm not going to write system, let's assume we have it inputted. Let's just see it written like this on the test anyways. And then we were to write minus A, we're just going to get, that's not even, how did I even do that? I was trying to write lowercase a. This is going to print out negative 20, okay? And unary plus is ultimately useless. It's just saying like, oh gosh, it's been a positive number, but you're not gonna, I don't think you'll see a plus sign. You might. I can test that and let you know. Okay, yeah, it generally just does nothing. It'll only say, oh look, the number is positive. Really, the unary minus is the only one that can do something. So then next we have casting. Now casting is a concept that we're gonna dive into a little bit later. It has to do with data types and stuff. Let's say I had an integer value. You see I've been working with int equals 6. And the thing with integers is they can only store integer numbers. What if I wanted to print out the decimal version of 6? Like what if I wanted to do 6 divided by 4 and I wanted to give me 1.5? Well, normally this would just give you 1 because you're dividing by two integers. That's called integer division. However, if I were to use the casting operator and cast, let's say 6 to be a double, then this 6 would become 6.0, and then you divide that by 4 and you get 1.5. And you can see here, this statement is operator precedence. This casting happens before the division, because casting is above division in the operator precedence hierarchy. That's why this gives you 1.5, There's no need for you to have to write, okay, there we go. There's no need for you to have to write parentheses around these or anything, because operator precedence will already take care of this, okay? Now let's move on to the next item on the list, which is going to be your multiplication signs, or your multiplications. And now we're diving into PEMDAS, which you should understand. I mean, we're going to go over it anyways. So you have your multiplication, you have your division, and then you have your modulus operator. So real quick, let's just go over these. If I was to print out, or if you're evaluating the expression, say int x, int x is 4 times 3 plus 2. This 3 plus 2 won't be evaluated first. Instead, we will evaluate that is green. We will evaluate the 4 plus 3, or 4 times 3 and get 12, and then add that to 2. For division, if this was the same scenario, that's again green. We'll do 4 divided by 3 plus 2. 4 divided by 3 is 1, because, and again remember, we're evaluating this first before we do anything with addition. Because as you'll see, PEMDAS addition is below multiplication, division, modulus in the operator hierarchy. So we will evaluate this expression first, get 1 plus 2, and we will get 3. Conversely, if we had int x equal to tilde 4 divided by 3 plus 2, what would actually happen here is the tilde would happen first because it's above division in the operator hierarchy, then the division, and then you'd add 2, and you'd get a really, really big number here. I don't even know if it'd be big enough to fit. I don't know if you get like integer overflow or something like that happening. You might even get an error. It depends. Anyways, but yeah, you'll get a really big number. Right, but I just want to show you just tying some stuff up here. And also, as I go over these concepts again, don't worry if you don't memorize them all right now. You're not really supposed to. This video is supposed to be a reference to all of them, and I'm probably going to come back to this list later on after when I individually cover all these different parts. Like you will by the end of this know what all of these things do. Don't worry about it right now. Think of it more as like a explanation, or as like a spoiler kind of, you know, trailer. Lastly, we have modulus. So modulus is just for taking the remainder. I think I explained this one already in a previous video. So 3 modulus 2 would return 1 because the remainder of 3 divided by 2 is 1. So if we had 3 divided by 2 plus 4 or something, we would evaluate this and get 1 and then add that to 4. You wouldn't do like 2 plus 4 and try and do 3 to modulus 6. That's not how it works. So this would get evaluated first because the modulus has higher authority than the addition sign. Speaking of the addition sign, that is next on this, and I'm having a really hard time remembering these operators' names, bro. It's literally just additional stuff. So we have the addition sign, then we have the subtraction sign, and yeah. So we have addition. You can use addition for 1 plus 2, or you can also use it to concatenate values to strings. If I had a string here, hi, this would give me 3, but this would actually give me 1 pi back as a string. If I had 1 plus 2 plus hi, well, Java runs this left to right, and you do 1 plus 2 is 3, and then you'd say you get 3 hi back. Okay, string concatenation. It's pretty straightforward, and we're also going to talk about it more in a later video, so I'm not going to bring it up too much right now. And then you have subtraction. 3 minus 4 is -1. Stuff like that, just subtraction, addition, your basic PEMDAS, right? Genuinely, this and then like this is all you really need to know for question 2. But I want to go over all of operator precedence in here just so because you will see more operator precedence questions. Now we're going to dive into shifting. I'm not even going to explain shifting right now. I'm going to make a dedicated video to bitwise operators. Essentially, just know it's like essentially what shifting is, you're taking a number and first let me write the shifts down. Like you're taking a number, like if we're doing left shift 2, left shift 4, you're taking the binary representation of this, and then you're just shifting it back 4. So you do like 1, 0, 0, 0, 0, something like that. And there's actually a formula for this that we will talk about later in the bitwise operators video. Now, right shift, instead of moving things to the left now, you're going to move things to the right. So we take that 0, 1, and now we start moving to the right. So we would go out of bounds, and then you would have a 1, and then so on and so forth. Actually, interested in seeing what this would return. I think we'll talk more about that in bitwise operators, but just know left shift, we're shifting the number left this many times. right shift, we're shifting the number right this many times, okay? That's a basic mentioning of it. We're not going to go into detail right now, we're going to go into detail in that video. And this is an unsigned right shift, which will pretty much always return you a really big number. I will explain why in that video aesthetically for it. I don't want to explain every single operator right now. If there's ones like these ones which I think are critical for operator precedence related questions, I'm going to explain them now. But these ones I really just want to do in a bitwise operator video. But I got that already planned out, you know what I mean? So below this we'll have your normal conditional operators. So you'll have your relational operator, sorry. Your less than is equal to, your greater than, and then your greater than is equal to. And it makes sense why this is more on the bottom of the list, because if you have an expression here, and you're doing this, and you have another expression here, you want to evaluate the expressions first, right, before you try to run this. And you might see occasionally like a plus 2, that's this error. Let's just return, let's say A6, let's just return true, let's just return false, let's just return a number, you know? You have to realize that this comes before this. So if A6, you're going to get 8, 8 is greater than 1, you're going to get true. But if you're unaware of operator precedence, you might think this run gets you true, and then you can't add true to a number, and you're going to get an error. And that's just a whole trap waiting for you, you know? So relational operators, if you're taking math courses, you know what they are. And the last one here is instance of. So instance of is if you're creating an object, you know, with a new keyword. Well, every object you make is a child of a class or an instance of a class. So if I had class, let's say I made an object A, and I wanted to see if it's an instance of the object class, it should return true because everything in Java is instances of the object class. And let's say another example. I'm creating a class, let's say I have a class called C. I'm creating an object called B equals new C, right, like this. Then if I check if B is an instance of C, I'm gonna get true. And again, you can see why this is in this category. You have to understand what this is and understand what this is, and then you can use this, you know. So real quick, I'm going to talk about operator associativity because I forgot to mention that so far in the list. And I kind of have an example of it right here. So if I was evaluating 1 plus 2 plus 3 plus 4, well, these are all the same operator. So how does Java know that you're supposed to start from 1 and go to 4? How come Java doesn't think, oh, let's start from 4 and let's go all the way back, you know? That's due to operator associativity. So you have to tell Java this. So at the top, we evaluate things from left to right. This, and then you're like this, right? We'd evaluate this expression first, and then this expression, left to right. And then this next set, the post-pre and post-pre increments are also left to right. Unary operators are right to left. They'll evaluate that. But don't really worry about how that works because if you normally try that, you'll actually error out. Low-key writing this code errors out your program. So in my opinion, it's stupid that's right to left because the only way you get it right to left is if you use parentheses. And then at that point, you know it's right to left. Some of these are just stupid, so I'm not going to explain them. Like, I think parentheses are kind of stupid to explain. This is kind of stupid to explain, but sorry, that's just me ranting. Because you don't need to know associativity to figure that out. Right, that's gonna go right to left. And same thing with casting as right to left, which makes sense. If this is actually important for me to explain. If I had a double here, and I had 3/5, well, this would become 0, and then we take that as a double. Right to left. That's evaluated. And then these are all your PEMDAS are left to right. Your relational operators here, your shifts are your right to left to right. And same with your relational operators, they also evaluate the condition from left to right. Right, it would go a run like this, it won't run like this. Though I don't think it matters really for these symbols. And also just remember, sorry, I'm using bad examples because remember associativity's been using multiple of the same. So if I was doing this, let's assume for even a second Java allowed the syntax, because it doesn't, it would be evaluated like this, not like this. Or if I was using casting and I was looking at int int of double of 4, it'd be evaluated like this and not like this. As examples of associativity, most associativity is kind of stupid because it'll error out your code anyways, but let's keep going and I'll include the associativity because I want this to be comprehensive. Okay, the next category here is equality. So it's not assignment, it's equality. It's checking if things are equal to each other, which you've seen if you use it before, or they're not equal. So if I were to say 1 is not equal to 2, then this would return true because that's a true statement. Versus if I said 1 is equal to 2, this would return false because, well, 1 is not equal to 2, so there's no way 1 is equal to 2 can be a true statement. You know what I mean? Pretty straightforward there, and that's evaluating it from left to right, I'm pretty sure. Yep, left to right. Moving onwards, we have bitwise. Ooh, interesting. I like this. So what you need to really understand is, except for not for some reason, the order of bitwise operators pretty much goes bitwise and logical. It goes and, XOR, then OR. So most selective to least selective. So I also bitwise and here. Note how I'm only writing one and. Bitwise and is singular. It's the singular and. So what does this do? If you had 1 and 2, it'll take the binary interpretations of these values and then compare them with and. So 1, it'll see if you're looking at 1, which is just this, and this, which is this, kind of overlaps like this. 1 and 1, that's true, but then 0 and 0 is just 0. So it's the same. I'm not going to dive into it right now because we don't have the time, and I really want to make my own video for bitwise operators. Well, but essentially that's and. Then you'll have XOR here, which is a little triangle carrot top piece. Next you'll have bitwise OR. And just note these all look at the binary interpretation of these values. And then you will have the logical and. So logical, this is actually important for ternary operators. Wait, this is really important for operator precedence. You'll be asked like this. So bitwise is above logical in operator precedence. So if they were asking you what comes first, this or this, which will be evaluated first, you know that this is evaluated before this. This comes first. Okay, bitwise has higher priority than logical operators. And remember the difference, bitwise operators look at the binary interpretations of values, so they work with numbers, versus logical operators look at Boolean values, so they look at Booleans, like true and false. Yeah, bitwise, or logical OR. And let me real quick, logical and, if both are true, it's true. If both are false, it's false. Or if only one of them is true and the whole thing is true. So this matter is false, we still get true. But if both of them are false, it'll be false. And if we jump back up here to bitwise, This is actually kind of how it works when we're comparing bitwise. If I had 5 and 4, we look at the binary of 5, which is 1, 0, 0, 1, and then 1, 0, 0, 0, except it'll return a 1 if both the values are 1, and then a 0 everywhere else for AND. It'll return if this was bitwise OR, so like this. It'll return a 1 as long as one of the two values is a 1. And then in bitwise XOR, it'll return 1 as long as one of the values. So if we had like this would also become 1. Okay, let's assume for the sake of the education content, we had this, which would be like what? 1, 2, 4. So I think 7. 7 compared to 4 is that? Right, you get 1 here, because yeah, either just for bitwise OR, just only 1 needs to be 1 for you to get a 1. And but conversely, if you had XOR, well, now it's a selective OR, so 1 has to be true and 1 has to be false. So now instead of getting 1, this would give you 0, but this would stay 1, and this would give you 0. Sorry if that was a bit confusing, because that's not the main focus of this video. It's not meant to give you that understanding of bitwise operators, because for the millionth time I said I'm making my own video to cover it. It's just to introduce you to these content. And these are all left to right. It's like most of the time it's left to right, unless you're like actually like assigning something to a value, saying a variable is equal to this. And speaking of that, we're down to assignment. So it's your equals, your plus equals, your minus equals, your all the different operators equals, right? Lambda equals, sorry, not lambda, freaking modulus equals, divide equals, multiply equals. It's just saying like, when you see something like this, if I had int a, let's say, times equals 2, it's the same thing as saying int of a is equal to a times 2, okay? And these, like I just said before, assignment is always going to be left to right to left. And there's a few more. And these are just like bitwise shifts, because bitwise shifts will give you a number. So you have left shift is equal to, right shift is equal to, and then logical, I think it's called logical right shift, is equal to. And these all are evaluated from right to left. And at the end, finally, we actually made this actually quick for a video. Yeah, 37 minutes is actually pretty good. So let me just bring this up here, and then just extend this line for one more little bit, and that is the lambda. So the lambda, or the switch that uses this notation, we'll discuss switch. It's actually used in modern switch notation. Lambda functions are essentially one-line functions. So if I had, I think it's written like this. I'm not too good with lambdas myself. And you have like your function in here, okay? We actually will talk about lambdas because they've tested it like maybe once or twice in the past. But yeah, lambdas are the very last thing, because you have to do an entire function. Functions can have all of this, right? You can do so much in functions, and then you're just assigning it to a variable. So essentially like creating, it's like a shorthand for creating a variable, creating a function. Actually, I think it's written like this. And this is to replace like a normal function. Okay, cool beans. So that was it and this is lambda or switch. I'm not going to draw two. And this is obviously right to left because we have to evaluate a whole function, right? In a lambda, it's essentially giving me, lambdas are essentially assigning a function to a variable. You're doing a whole function and then you're assigning a variable. So that is operator precedence. Now, don't worry if some of these operators confused you. What you need to take away from this is the order that these operators are in, ideas of what post-increment and pre-increment do, because we discussed that. PEMDAS, important. The idea that bitwise operators go above logical operators, you don't need to know what they are. You need to know that they are above them. So bitwise operators are above logical operators. The assignment is typically always at the bottom. The last thing is a lambda, pretty much always. No, literally always. It's the last most thing that gets evaluated. And so yeah, and most programmers don't even use these. Typically, you'll just do a bunch of parentheses for your stuff. Force your operator precedence. However, UILCS wants you to understand this concept. So here is the chart for operator precedence. I can zoom out a little bit maybe to give you guys a better view of it all. And we have the associativity. Make sure you understand what associativity is. It's the idea that if you had multiple of the same operator, where do you evaluate? Do you evaluate, like if I had, do I evaluate from left to right, or do I evaluate from left to right, or do I evaluate from right to left? Associativity determines that for multiple of the same operator. And yeah, that was operator precedence. For the terms of question 2, you only need to know your PEMDAS, parentheses, exponents, multiplication, addition. And if you don't even know PEMDAS, you can just look at this chart and just see, oh, multiplication, division, modulus, they're above addition, subtraction. Oh, parentheses is above all that, like that. And yeah, that is going to be operator precedence. Oh, one more thing, PEMDAS. No, that's it. Question 2 is generally just PEMDAS. Even on the state level, I checked, it's just PEMDAS. You should be able to breeze through that question in no time. But I want to go over operator precedence as a whole because you need to understand this concept for numerous questions, even past 2 on the UILCS written exam. And yeah, that was today's video. Sorry there's been a gap. I was studying for Python, time of Python competition. But now that UILCS is approaching, it's time to get back on that UILCS grind. Thank you for watching. The next video is going to be, the next video is actually going to be pretty good. It's going to be about print statements, println. You might have seen me do that out.println. Might have been confused what that means. We're going to discuss this and a bit more, including the printf, which they just love testing, bro. Oh my god, they test the freak out of printf, bro. You'll see all that in the next video. So yeah, stay tuned for the next video. Let's go over Q3. That should be relatively quick. And yeah, that was operator precedence in Java. And subscribe, I guess. I'm gonna be uploading a lot more. Subscribe if you want to. You don't have to. I don't really care. Either right now. It's just videos that are out there.